Good morning, grade nines. Hopefully you had a good long weekend. If you haven't finished the Unit 4 test, you need to do that immediately and make sure you submit it to D2L. I will be spending the rest of the week marking. Some people are asking me, I'm giving you updated marks. I thought marks couldn't go down. You're correct. On the main report card, your mark will not go down. So whatever you had in March, you'll have at the end of the semester unless it goes up. But I will still give you your updated marks so you know where you are and how you're doing. So yeah, that'll be updated as regularly as possible so that you know the situation. And I guess my justification is it's helpful to know, especially for those that want to get their mark higher, to know that their hard work is paying off. And then also, if you're one of those people that was already really high and you find that this is a little more difficult and your mark's going down a tiny bit, I think you're going to be still motivated to finish the work because you know that grade 10, they are going to assume you know some of this stuff or all of this stuff, and you don't want to put yourself at a disadvantage next year. So you're going to continue to work this year to get the grasp the content and be prepared for grade 10. So that's why I'm giving you updated marks. And if they do go down, that's just a result of your assessment being lower than your average. But your overall at the end of the semester will not go down. So that's your mark at the end of the semester, the one that goes on the report card, is going to be the one that is either your March mark or higher. In between, I'm giving you updated marks to know exactly where you are in the course. Okay, so let's get started with the Unit 5. This is the end of lines. It's really just a little bit more that we had to cover off, and then you have the basis of lines, which is your expectation in grade 9. In grade 10, you're going to review lines at the start, and then you're going to move into what's called quadratics. They're curves, and that's grade 10 is grasping quadratics. It's the next step. So the grade 9 step that you need to know is lines, and hopefully by the end of this, you're feeling pretty confident. I will be doing homework checks as well. Sorry, not homework checks. Homework review / question periods, interactive ones, and we'll do that later in the week so that people have a chance to do some of the homework, and then they can ask the questions. And like I said, the lines is almost done. We're almost moving on to new concepts. So let's get started. Lesson number 5, or Unit 5, Lesson 1, depending on how you look at it. So 5th lesson since we went into COVID is, well, first of all, the cost to attend a local carnival can be modeled by the equation C equals 2.5x plus 13, where x represents the number of rides you go on. So C equals 2.5x plus 13, where x represents the number of rides you go on, and C is going to be the cost. So cost 2.5x plus 13. Determine the slope and the y-intercept for the situation. Explain their meaning within the context of the problem. So the problem is, it's the cost to attend a local carnival. Now, just take a step back, you should already know y equals mx plus b, where that is slope, and that is y-intercept. Y equals mx plus b, we got slope, we got the y-intercept. So you already know that. So what you have to do is look at the pattern, the y equals mx plus b, the general form, and then take a look. And if this is in the form y equals mx plus b, then we're all set. And we've got y equals mx plus b, we are all set. So right away, we can get the slope and the y-intercept straight from the equation. So that's what we're going to do. So 2.5 here is the slope, and it's the number of rides is x. So the slope is telling you that it's going up by 2.5 every x, or every ride. So you're spending 2.5 or $2.50 for every ride that you take. That's the 2.5x part. There's your slope, 2.5. And then your y-intercept is the 13. Now, the cost at the carnival is 2.5 or $2.50 per ride, plus the 13. And if any of you have been to a carnival, Western Fair, for example, there's a possibility that you might have had to pay to get in. Or maybe Western Fair doesn't do that, but Canada's Wonderland might. So the 13 is the y-intercept, and that's how much it costs to enter the park or the carnival. So there's your y-intercept at 13. If you go on 0 rides and you just go to the carnival, you've paid $13. Every ride you take is an extra $2.50. And that's the y-intercept and the slope in the context of the question. Always remember, slope is a rate. So if it's per something, that's your slope. Any kind of question that says per or gives you some type of rate, that's your slope. Your y-intercept is a fixed cost. So entry fee, you have to pay it. Even if you do nothing else, you just go and you pay the entry fee. That's your fixed cost with 0 rides. So, next question. How much would it cost to attend the fair if you went on 11 rides? So again, you need to get the equation. Y equals 2.5x plus 13. I'm just going to rewrite that. And instead of an x, I'm going to slip in 11 rides. So the cost is 2.5 times 11, because you have $2.50 per ride, 11 rides, and then an additional $13. So $2.5 times 10 is $25 plus $2.50, $27.50. Plus the additional $13 just to get in. And you end up with $40.50. Okay, so if you wanted to go to the carnival and you wanted 11 rides, you're looking at about $40.50 in costs. If you brought $60 with you, so this is C, if you brought $60 with you, how many rides could you go on? So the cost, if you brought $60, you could have a cost of 60. So I'm going to just change it up a bit, and we're going to put 60 on the cost part. So you got $60 to spend. How many rides could you go to? So there's your equation, $60, 2.5x plus 13. Because the 60 you brought, you can spend. So your cost could go all the way up to $60. Now, here is where that unit that we did at the end of our in-class session, so in March, the algebra, that's where this keeps coming up. And I've said that that's like one of those fundamental units, because it's a skill that you're going to use over and over again, and here you're going to use it. So I want to know what x is. How many rides, or what x makes this a true statement? And the way to do that is to isolate x. To isolate x, remember, you need to use reverse bedmass. So you go in the opposite order, reverse bedmass, and you're undoing what's being done to the x. So right now, what's being done to the x, you're multiplying by 2.5 and you're adding 13. In reverse bedmass, you want to get rid of the 13 first. So subtract 13 from both sides. So now you have 47 equals 2.5x. So there's our first step in reverse BEDMAS. Now what's being done to the x is a multiply. To undo a multiply, you divide by 2.5 and you're left with x. And you divide by 2.5. So 47 divided by 2.5. And remember, when we're talking about this kind of stuff, we're talking about a teeter-totter. The equal sign represents the teeter-totter. What you do to one side of a teeter-totter, you have to do to the other side of the teeter-totter. And so now I have my calculator. And we're looking at 47 divided by 2.5. You're looking at 18.8 rides. So really, in the grand scheme of things, you can't have point something of a ride. 18.8, so really you can only do 18 rides. And you'd have some change, but you got 18 rides at the carnival.